Welcome to the lecture on problem solving based on equivalence and methods of comparison of alternatives. So, in this lecture we will try to solve problems based on equivalence as well as on the different criterion which we have discussed about the comparison of alternatives. Let us discuss the first question. The first question tells that a mutual stock fund has grown at a rate of 12% compounded annually since its beginning. It is anticipated that it will continue to grow at this rate. How much must be invested every year so that rupees 60,000 will be accumulated at the end of 12 years. So, we can solve this problem. What is given is, we will write first, we have been given I is 12% compounded annually. Then it is said that rupees 60,000 will be accumulated at the end of 12 years. So, n is 12 years and f is given as rupees 60,000. So, basically you have to find what should be invested every year. So, basically the cash flow diagram will be like this. So, at the end of 12 years you need rupees 60,000 should be accumulated. So, at the end of 60,000 12 years the rupees 60,000 is to be here. Now, you need an equivalent amount basically So, basically you have to find the equivalent amount A which should be deposited so that this is equivalent. So, you have to find this A which should be deposited every year end, which should give you 60,000 at the end of 12 years. So, you are given f, n and I, you need to have A. So, for finding A, the equivalent value of annual deposit, what you will do is A will be nothing but f times, you have to multiply with the factor A by f I n. So, I is 12 and n is also 12. And this factor value we can refer from the table A by f 12 12. So, this is a 12% table and for 12% for 12 years the A by f 12 12 is 0.04144. So, it is here. So, 0.04144 60,000 multiplied by 0.04144, and once you multiply this it comes out to be 2486.4. It means if you deposit rupees 2486.4 for 12 years at 12% interest, you will get 60,000 rupees. So, this 2486.4 is the required answer. Next question we will discuss. The next question is, what single amount at the end of 5th year is equivalent to a uniform annual series of rupees 1000 per year for 12 years. The interest rate is 12% compounded annually. So, basically in this question you have to find the single amount at the end of 5th year. So, the cash flow diagram can be drawn first. Now, in this cash flow diagram you need to find the single amount at the end of 5th year. So, you want to have the amount here. Which is equivalent to uniform annual series of 1000 per year for 12 years. Now, for this the equivalent cash flow diagram is and you are given as 1000 rupees. Now, for solving such problems what you have to do is, first of all you have to find the equivalent value of this series at present time, and once you get its equivalent value at present time you can further get its equivalent at a future time. So, the present value for this whole equal series will be, now let us see, this we can write as P5. So, we need to have first P0. So, P0 will be, if this is where P0 is indicated, P0 will be nothing but A times P by A I n. A is given as 1000, I is 12%, n is 12. So, P0 can be found as 1000 times the factor P by A 12 12. Now, P by A 12 12 you can get from the interest factor table. So, P by A 12 12 you can have this P by A 12 12 is 6.194. 6.194. So, 1000 times 6.194, that is 6194. Now, this amount is the equivalent amount at 0 time. We have to find equivalent amount at n equal to 5. So, this amount should be multiplied with f by p 12 5. So, this P0 and P5 will be equal to P0 times f by p 12 5. So, P5 comes out to be 6194 times f by p 12 5. Now, f by p 12 5, again we have to see the value. F by p 12 5 is 1.7623. So, once you multiply this number 6194 multiplied by 1.7623, this comes out to be 10915. So, this is how we can solve such problems. Now, we will discuss about the problem of internal rate of return, where we had discussed that what will be the internal rate of return for which PWI will be equal to 0. So, let us see what we had received, the cash flow diagram. Now, in this we had the disbursement of 10,000, 8,000 and 5,000 as receipts, and 12,000 as the receipt. So, what we had seen is PW 12 will be minus 10,000 minus 8,000 P by F 12 1 plus 5,000 P by A 12 3, that will be defined here, multiplied by P by F 12 1 plus 12,000 multiplied by P by F 12 5. So, this can be taken as minus 10,000 minus 8,000 P by F 12 1. So, P by F 12 1 is 0.8928 plus 5,000 P by A 12 3. So, P by A 12 3 is 3.037, no, it is 2.4018. So, 2.402 multiplied by P by F 12 1, that is 0.8928 plus 12,000 multiplied by P by F 12 5. So, P by F 12 5 is 0.5674, that comes out to be minus 10,000 minus 0.8928 multiplied by 8,000. So, that is 7142 plus 5,000 multiplied by 2.402 multiplied by 0.8928, that is 10722 plus 12,000 multiplied by 0.5674, that is 6808.8, and that is equal to minus 17,142 plus 1 17,530.8. So, 17,538 minus 17,142 is equal to 388. So, what we have seen is we had calculated at 0% rate of interest PWI, and at 12% the value is only a small value 388. Now, let us calculate the value at I equal to 3. So, at I equal to 13, sorry. So, at I equal to 13, PW 13 will be minus 10,000 minus 8,000 multiplied by P by F 13,1 plus 5,000 P by A 13,3 P by F 13,1 plus 12,000 P by F 13,5. Now, again we have to see the interest table of 13%. In the 13%, P by F 13,1, P by F 13,1 is 0.8849, so 0.885. P by A 13,3, this is P by A 13,3, this is 2.361. And P by F 13,5, P by F 13,5 is 0.5427, so 0.543 we can take. So, if we do the multiplication further, we have minus 10,000 minus 7080 plus 5,000 multiplied by 2.361 multiplied by 0.885. So, it is 10,447 plus 12,000 multiplied by 0.543, that is 6516. So, 6516 plus 10,447 minus 10,000 minus 7080, that comes out to be minus 117. Now, see that for 13% interest rate it has gone negative. So, it has come here. For 13% it has come negative. It means at some point in between, this point will be the rate of return. Now, this point can be found by using the interpolation method. What we see is PW12 is coming as 388 and PW13 is coming as minus 117. So, the interest at which it will be 0 will be PW I star, where it is 0 will be I star equal to 12 plus 0.885 0 minus 388 by minus 117 minus 388. So, it is nothing but 12 plus 388 by 505. So, it is coming close to 12.8%. So, what we see is, now what we see is the I star, by using the interpolation method we get this value, for this value the present worth is coming as 0. That is why this I star of 12.8% is known as the internal rate of return. So, you can solve the problems based on that and get the confidence more and more. Next question what we will discuss will be, you have to find the initial deposit amount which is required for maintaining a park forever. The park is made by the municipality and the maintenance cost is to be borne by the society. So, a maintenance work is to be done forever for a park which is made by the municipality. The maintenance cost is estimated as rupees 60,000 and interest rate is taken as 12%. So, this is a case of perpetuity type of cash flow where you need this amount for ever. So, we will use the capitalized equivalent concept to find the initial deposit for such cost which have to be incurred every year for maintaining the park. So, as we have discussed, the capitalized equivalent amount is nothing but A by I. So, it is nothing but this amount which you have to get forever. Now, in this case A is given as 60,000 and I is given as 12%. So, the initial deposit which will provide a sum of rupees 60,000 forever, that is capitalized equivalent at 12% will be 60,000 divided by 0.12. So, this comes out to be rupees. So, rupees 5 lakh amount, if there is initial deposit, it will give you an interest of rupees 60,000 in other sense, which will be used for maintaining the park forever. So, such problems you need to solve frequently and you will get more control over solving these problems. Thank you.